Now we're going to be looking at some properties of equality. These are actually things that might seem familiar to you from algebra. We're just giving them some formal definitions. So in this table, we want to assume or let A, B, and C be real numbers. So just numbers, right? And then we're going to talk about our properties and kind of see what they would look like. So the first one is called the addition property of equality. What that says, if A equals B, then you can say that A plus C equals B plus C. In other words, what this property does is if we have an equation, we are able to basically add the same number to either side of our equation and still have it be equivalent. So think about when you solved algebra equations, right? To get rid of subtraction, you would add the same number to both sides. That is using the addition property of equality. So adding a number to both sides of the equal sign. So the subtraction property of equality says if A equals B, then A minus C equals B minus C. So the subtraction property lets you subtract the same number from either side of the equal sign. The multiplication property says if A equals B, then A times C equals B times C. So in other words, you can multiply both sides of an equation by the same number. And then last one like this, division property of equality says if A equals B, then A divided by C equals B divided by C. And we need to mention in here, we're going to put in parentheses when C does not equal 0 because we cannot divide by 0. So if A equals B, then A divided by C equals B divided by C as long as C does not equal 0 because you are allowed to divide both sides by the same side. So that's again just like when you're solving an equation, right? Doing your opposite operations. These ones might seem a little bit new to you. The first one here that might be new is called the reflexive property of equality. Reflexive, think reflection, right? If you look in the mirror, you see yourself. So the reflexive property lets something say that, or let us say that something equals itself. So maybe you have something like A equals A, right? That would work because something is equaling itself. You could also say that with some of our geometrical terms, like the measure of angle B equals the measure of angle B, right? That's saying something equals itself. The symmetric property, symmetric, think symmetry, right? If you fold something down the middle that's symmetric, it's going to line up on either side. So the symmetric property says if A equals B, then B equals A, right? So it's kind of, imagine if you were to fold A equals B and B equals A in half, right? That would line up. It's symmetrical on either side. So something we could say here, it's a little more mathematical, maybe like if X equals 2, then 2 equals X, right? Same thing, just reversed around. That's a symmetric property. Transitive property lets us say if A equals B and B equals C, then A equals C. The reason for that is if A equals B and B equals C, they both equal B, right? Both numbers technically equal the same thing, where both parts equal the same thing, so they equal each other, right? They both equal B, so they equal each other. So maybe if I said something like XY the measure of segment XY equals 5, and 5 equals the measure of segment ZW, then you can say XY equals ZW, right? They both equal 5, so they equal each other. Substitution property says if A equals B, then A may be replaced with B. In other words, you can plug something in for something else if they're equivalent. So think like plugging something into an equation. If I gave you x equals 2 and x plus 3 equals 5, then what you could do here is plug 3 into your equation in place of x. Right, so we could take our 2 and plug it in for x and say that 2 plus 3 equals 5. So I'm substituting that into my equation. And then the last one is the distributive property that says if you have A times B plus C, then you can distribute that A and get A times B plus A times C. The ones that people struggle with the most here are reflexive, symmetric, and transitive. Those are the ones people are most likely to confuse with each other. A certain way to kind of think about it, the reflexive property always deals with just one thing. Something equals itself. The symmetric property always deals with two things, right? Two things that are flipped over the equal sign. So the order doesn't matter there. And the transitive property always deals with three things. A equals B, B equals C, so A equals C. Two things equal the same thing, so they equal each other. We're going to look at some examples here. So example 2 says state the property that justifies each step. So we just need to say which property from our list above is being shown here. Now what these are called, you learned about these kind of statements during the 2.1 notes. These are if-then statements. So if our hypothesis, then our conclusion. So like in part A, our hypothesis is that 5y equals negative 20, and we're concluding that y equals negative 4. What this is saying is which property allows you to get from your hypothesis to my conclusion. If I know that 5y equals negative 20, then what property can I apply to say that y equals negative 4? Well, think if you were just solving an equation. If I gave you 5y equals negative 20, you would divide both sides by 5, and you would end up with negative 4. So since you're dividing both sides by 5, this would be the division property. And you're welcome to abbreviate property, but you do have to write it. If all you say is division, that's only partial credit. Using division is different than using the division property. You can divide any two numbers. I can say 4 divided by 2 is 2. That's division. The division property specifically says you're doing something to the left and the right-hand side of the equal sign. So part B says if the measure of AB equals the measure of CD, and the measure of CD equals the measure of EF, then the measure of AB equals the measure of EF. Well, if you look at this one, we're dealing with three different things here. We have the measure of AB, the measure of CD, and the measure of EF. Our hypothesis is saying the measure of AB equals CD. CD also equals EF, which then implies that the measure of AB equals the measure of EF. So according to your given, both measurements equal CD. So if both measurements equal CD, then they equal each other. So this would be the transitive property. No, part C, if 5 equals x, then x equals 5. So for this, we have the same thing but flipped around, right? So 5 equals x and x equals 5. If you folded that in half, that would line up. X would line up with x, equals lines up with equals, 5 lines up with 5. That means it has symmetry. So this is the symmetric property. Okay. Part D, the measure of xy equals the measure of xy. That's something equals itself. That's the reflexive property. Part E, if x equals y, then negative 2x equals negative 2y. So here we just started with x and y. What property allows us to say that if x equals y, then negative 2x equals negative 2y? Think about what changed from your if to your then. We had just x and y. Suddenly, each side is being multiplied by negative 2y. The property that lets us multiply both sides, so again, we didn't have any numbers. Now suddenly, left and right side are being multiplied by the same number. So since both sides are being multiplied, that is the multiplication property. Number 4, if the measure of A equals the measure of angle B and the measure of angle B equals 42, then the measure of angle A equals 42. Both parts here, if you look at your given, both things equal the measure of angle B. So if the measure of angle A equals B and the measure of angle B equals 42, right, they both equal B, therefore they equal each other. That is the transitive property. Part G, if x equals y, then 2x minus 6 equals 2y minus 6. This actually is two different properties. We started with just x and y. Now suddenly both sides, we're subtracting 6 from either side, and we're multiplying both sides by 2. So again, we went from having nothing to both sides being multiplied by 2 and both sides having 6 being subtracted. So this is both the multiplication and the subtraction property. Also, if you're going to abbreviate, please do not abbreviate subtraction as sub, because if you just put sub, I won't know if you're talking about subtraction or substitution. So then last one for this example, if the measure of angle A equals the measure of angle B, and the measure of angle B equals 42, then the measure of angle A plus 10 equals 52. So here what happened is we know that the measure of angle A equals the measure of angle B, right? And the measure of angle B equals 42. From our hypothesis, since they both equal the measure of angle B, we can then conclude that the measure of angle A equals 42, right? That's the transitive property. But then if you look at your conclusion, that's not what quite was concluded. It says the measure of angle A plus 10 equals 52. Well, where are they getting that from? Well, if you take 42 plus 10, won't that give you 52? So they also took 42 and substituted it in place of the measure of angle A. So this is actually both the transitive and substitution properties. And then last example for this video is example 3. Use the property to copy and complete the statement. Well, we already have the statement copied, we just need to complete it. So it's telling us what property to apply here. It's giving us our hypothesis. We need to finish our conclusion. So it's telling us to use the addition property of equality. If the measure of angle J equals 30 degrees, then the measure of angle J plus the measure of angle K equals what? Well, it told us to apply the addition property, and if you look here, we went from a hypothesis that had no adding at all to suddenly we're adding the measure of angle K on the left. Well, according to my addition property, if I add the measure of angle K on the left, I have to also add it on the right. So I'm going to take my right-hand side, which is 30, and I'm going to add the measure of angle K to it. Again, our property says if you add something to one side, you have to also add it to the other. Okay, so that's what we did there. Part B, reflexive property, that says something equals itself. So if I'm told to use that and I have the measure of angle or of segment GH equals, I know that's going to equal itself, which is the measure of segment GH. Distributive property, if 3 times the quantity x plus 7 equals 30, then, so it's telling me take my hypothesis and apply the distribution property. 3 times x is 3x, 3 times 7 is 21. Multiplication property of equality. So remember, that says if I multiply a number on the left, I have to multiply that same number on the right. So if the measure of angle J equals 30 degrees, then 2 times the measure of angle J equals what? Well, so in my hypothesis, I had no multiplication. Now I'm suddenly multiplying the left by 2. Well, if I multiply the left by 2, I have to multiply the right by 2, which would be 2 times 30 degrees. Or if you prefer, you can just put 60 degrees. And then last one for this video, transitive property says if the measure, or apply the transitive property, it says if 3x plus y equals 7 and 7 equals 5x minus 2y, then what? Well, the transitive property says if two things equal the same thing, then they equal each other. And if you look at your hypothesis, both of these equal 7. So according to our property, if they equal 7, then they equal each other. So I can say that 3x plus y equals 5x equals 5x minus 2y. Okay. And then in the last video, we're going to look at some 2-column algebraic proofs.